because that's the, I'm sorry, the authentication response message, because that's what I'm expecting to come back. And if that cache doesn't work, then we've got really big problems. But that's a full duplex scenario where I am going to wait. I'm not going to publish a message. I'm going to send a message, and I'm expecting a response to come back. And we're handling that with this asynchronous callback right here. So when I do this, I'm just making an assertion that I have some sort of authentication ID and that the roles were returned and some stuff that's specific to that particular implementation. If we go in here and look at the unit tests, when logging in with valid credentials, and we have the bus, but the bus is being mocked, which you can see down here. So what I'm going to do is when I'm logging in with valid credentials, I want to verify that I pass authentication, that the user is being updated with the current security token, that I get a list of roles back that the user applies to, and that the user ID is returned to me for that user. If you're doing this, it's very easy to make determinations on where everything is supposed to reside within a distributed system when you drive it out through unit tests. This will answer a lot of questions. So I'm making a request. There's the credentials, auth credentials. Here's where I'm mocking some stuff that's going into service layers. And my bus is right there. I just mocked the bus, the iBus interface. But the only thing that I can unit test, and this is where people have big problems trying to understand this, the only thing that you can test is that you actually sent a message in a unit test. Even in in one-way messaging scenarios and integration tests, that's all you can test. You typically do not publish a message and then cross a service boundary to open up somebody else's database to see if they put your message in. That's a completely different system. So we only test within our own service boundaries. If we go back, here's the request response example out of in-service bus, which you can see the full duplex. Again, same thing, bus.send.register. Are there any questions? Because we got like 15 minutes or 20 minutes. We're going to get out of code a little bit and go back into the system stuff. No questions? No? 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 There might be one other good example in here. So who's building large enterprise systems? You are? You are? You guys are? What's your system design like? Have you considered messaging scenarios? Think about people don't realize, I mean, even shopping cart applications. When somebody places an order, when they add an item into the cart. Now, if it's the first item that goes into the cart, there's several things that have to happen. You have to create the cart, you have to create the order, you have to allocate the item out of inventory. Because if they order 2 and you only have 3, everybody else that's shopping on the site can't see that you have 3 because you really don't. Even though they haven't ordered it yet, they've allocated 2 of those. So everybody else needs to see that there's only 1. So there's several things that have to happen. Now, all of those things happening can take some time. The problem with a request response scenario in that case is that when they add an item into their cart, they have to sit and wait for you to do all of that. You have to contact the inventory system. You have to say, do we still have enough? And if we do, I need to allocate this amount. And then you've got to go to an order placement system, create a new order, and add a new line item to that order saying, this is what's going to be purchased. And then you've got to update their cart within your system. And depending on the type of implementation you have, there may be several other things that have to occur. All the while, that little hourglass is spinning on their webpage waiting for a response to come back. You shouldn't have to do that. When they add something into the cart, you just say, okay, I'll take care of it. Now behind the scenes on background threads, we're firing off messages to handle all of that other stuff. We'll add the item into your cart and then say, okay, it's in your cart. But when you added the item into the cart, you fired off a message that said, I need to allocate, this amount out of inventory. And I also need to create an order. And the system is waiting for some sort of acknowledgement behind the scenes on background threads while your user is still buying stuff. They're out there buying more stuff. Many, many, many systems have the need, especially for high availability systems, have the need for messaging. People don't think about small concepts just like that, like a shopping cart, the things that have to go on. You're impeding your customer's ability to spend more money when you're making them wait. And that's where messaging comes in, distributed messaging systems. If you're doing very, very large systems, if you've got 1 million users, then it's much more important. You can't have everybody waiting on full duplex scenarios as they're going around shopping on your site. It's, yes, sir.
I'd like to ask about special kind of message. It also says it's good to have command query separation. Yeah? You said about command query separation. And what is a command object? Does it contain business logic?
Okay. He's asking about command query separation. What do command objects contain? Look at the concept of just command and query. Queries are requests for information. That's what you're doing when people are shopping around on your site. This is why we have the command query separated architecture. Most everybody is around shopping on your site, which means they're pulling information out for display. And you have to have a database optimized for that. And a transactional database is not. Commands change state. Queries never change state. Anytime that you make a query into a system and it changes state, that's an anti-pattern. That's a bad deal. You should never expect data to be changed when you're querying for information. That's the goal of commands. Commands, never, I say never, there's a couple of exceptions to the rule. Commands typically only change data and never return data. When you create something, or insert something, or update something, you're just asking it to do just that, to change the state of the system. Once that request is done, then you can query the state of the system. And in a command query separated architecture, that's even more prevalent because it's two different systems. One is a transactional system that's recording that command transaction. And again, CQS architecture rarely has deletes and never has updates. All it is it's a new transaction that says, I changed the state, I changed the state, I changed the state, I changed the state. And the very last transaction that went through, that's the one stored in the query database. If we go back and look at let's look in here. These are all queries. They're out of the repository. Find by username and password, find one. They never ever change data. They